Alright, so thanks for bearing with me. I'm going to build this Tweedsville pedal. I thought it'd be good to do a video because I'm just going to be building one. I'm not building a batch. That way I can test out the circuit board. And yeah, it'll be good because I can do it sort of circuit board through to assembly. Obviously the box is already prepped, so that's a lot of the work done. I've got the wires prepped this morning and I'm just going to hit it, see how far I can get, and hopefully get through the video, have it assembled. If there's no network dropouts, I might chuck this up on YouTube, so you might be watching it there, or on Facebook streaming live. So I'll tilt my head up on this little head cam. I've got my bill of materials printed. I normally don't print because I don't like wasting paper, but at least I've sealed it up and they'll be there for the life of this circuit. So I'm going to start with the lowest level components. I know they are the small signal diodes. There's only one of these. It's not actually signal, it's a Zener for the LED. There's a 6V2 Zener in series with the LED, in series with a 220 ohm or 240 resistor. So I know it has one of those. Next up, I don't think there's any small resistors on this, so I'm gonna guess the diodes, got some 1N5819s or 5819s, I don't know what you guys call them. So it's pretty messy here. I've got boxes of stuff. It's pretty candid. I thought this might encourage me to tidy up my office. I'm not sure if I let people in to see what I'm doing. So there's diodes there, 4 of them, D1, 4, 5, 6. That naming was a bit odd. And I'll pre-bend these. These have to get bent down pretty firm because they're pretty tight on the board. Usually my resistors, I just flick them down. These power management things I just decided to keep tight so that they would be tight. So 1, 4, 5, 6. 1. I mean, they're pretty obvious. This is a really simple board. It's a simple circuit, and that's what makes it so good. 4. 6. I'm just putting a little kink on the other side so that they stay firm. Not that it really needs it. Make sure they're straight, make sure they're polarized right. Clean that tip, it's a bit gunky. I'm going to stay on these just a moment because it is such a thick leg. I want the solder to come through to the other donut on the other side. Because that leg is going to heat sink it pretty well. So I'm just sitting on them a moment longer than normal. Alright, where are my cutters? Out of these, I missed 2. I'm distracted because people are watching. Out of these, I'm going to keep these clippings. I've got, yeah, the small diode ones. Diode ones are good, they're long, and these ones are nice and thick and fat. Sometimes they come in handy. Board hookups and stuff, waste not. That's why through-hole parts are expensive. You throw a lot of it to landfill, to waste. Okay, what will be next? Probably just load the resistors upwards. These are fat resistors, that's why I haven't put them in. Usually I chuck in resistors before the diodes because the diodes are thicker. So resistors, 220. I've been trying to make a little box full of the Mojo high wattage resistors. So I think most of them I should find here. 220, made in Japan. Sealed up for some reason. $220, so I'm just checking my bill of materials, goes into R5, and that's just a soft fold. R5, I can see that's going to come up to power the LED, through 9 volt, through the resistor, through the LED, through the diode, return, through the switch. You can see up. These ones, you can either pinch them inwards or outwards, both work well, because it's wider. Alright, let's punch through this. I need a 2K. Let's see if they're here. 1K. 330, they're out of order. No, it's not there, so maybe it's... Yeah, I didn't have many of them. I'm slowly moving. Yeah, I'm slowly moving everything anyway. Place for everything. Everything in its place. Squish them in. Okay, 330, I just had them. That is R3. In regards to this, I've only got 2 of these boxes. They're both sold, but as you can see, there's boxes of boxes everywhere. It's boxception. These will be, I think, oh, they're up on the website now. I've got to build it now. I'm assuming the boards are all good, but I'm testing one out anyway. It's a known circuit. It's very simple. I know what it's going to do. There's nothing funny going on. But yeah, they'll be up. The regular Tweedsvilles. There's a look at them. Sorry if my internet's a bit dodgy. Hitting through 3K3. I think I saw those in here. Yes. That's a metal film. 1K. 8K2, so they might still be over here. They are. So yeah, it's quite a candid mess. But it's often a lot worse than this. R2 is the 3K3, I can see here. And there's not many bits on this board, so we're getting through it quickly. And 2 of 2M2 is the last resistor. 2M2, I think, will be over here. These ones I've opted for a metal film because it's the bias resistor. It's a dirty sort of biasing method. And 2M2 is a very large value. If you might as well use metal over carbon for noise reasons. There's no advantage to using carbon. And 2M2 of carbon would be pretty... It might not be noisy, but you're asking for something extra, like this, unnecessarily. And it adds up. Pedal here, pedal there. Stage here, stage there. How many buffers are there in all your stages and how many processing points are there in your pedal chain. Think about it. R1, R7, moving on. I am rambling. Well, no one's talking back at me on Facebook. Making a mess of this. Wasn't fitting quite as I thought. Let's try and get it to come down evenly. The spacing isn't quite perfect, but it works well. And the other 2M2 is just a bleed off. I had to do it on the input. Well, I didn't have to because the input's grounded when it's in bypass, but I'm doing it anyway just for those milliseconds where it's latching to the other pole, other throw. All right, rock and roll. Not very many resistors, eh? Very simple, very raw circuit. That's why it's good, I think. It's very musical in that way. It's your instrument with an effect, not caked over. It's just distorted in a nice way. One stage. I'm just sort of spinning around, getting what I can. A lot of space on this board, so it's a pleasure. As I'm cutting these, I'm just grabbing them with my finger on the other end, or you can just push it, support it in some way, otherwise they fly off. See, that one just went nowhere. And then the people you're living with, they get angry because they're like, oh, I got this bit of wire in my toe. I'm like, well, pull it out. I'm like, there's another one. I'm like, well, they're there every day. Yeah, people are. Jeez. What's missing is an inductor. I left that because I figure that's, yeah, it's just a slight bit thicker than the resistors. These have a firm fold downwards too. Hey Sarah, welcome back. And it looks like a resistor, it's blending in. The inductor isn't in the originals. So on that note, this is Tweedsville, based on, everyone's got their version of it, well not everyone, but very popular when boutique was happening. This is based on the Electro Distortion, which is just a single stage Class A boost, going into some diodes. It's very raw, it works immaculately. Very similar to the Les Lius. This is actually the same thing as the Les Lius with the boost engaged. That solder didn't come through both sides there. Let's go try it again on the back. It probably won't work, but I'll try and I'll let it sit there a sec. Nope. I'll just touch the plastic with my iron. So I'm just going to do one on the other side, which sucks because it's going to put this little wet spot of flux. And it probably, I'm almost certain that it wasn't necessary. It just bugs me to see solder on one side missing. Just like, what, did I miss it? Did I? Yep. So what else have we got? Why are there two inductors? I didn't know there were two. Inductor. Did I just put this in the wrong thing? Uh-oh. Did I? I'm certain I did now. Crap! So what was that meant to be? C1. I thought it said L1 or I1. Well, Well. Crap. Because everyone's watching. Alright, well that's candid. I'm just going to clean this out. I used it today and it's got heaps of crap. Right on. So, such a simple board. I made a mistake. I'm going to suck it out. That's annoying. Let's give it a crack. The spare solder, I'm putting it in the bath over there, whatever comes out. So it's going to come out with a little bit of gold on it as well, which will contaminate my mix because these boards are gold plated. How do we go? Not quite on either. So what I'll do is probably this. I'm going to trash this inductor now because I'm making it look ugly. So that's a waste. I could have fired up, I've got the solder sucker over there, but stuff like this, I could probably just do it old school. Yeah, whilst everyone's watching me trash a board. That's worked out okay. The other one, it sucked, I just need to flow it because it's grabbing the side, and that's okay. Did I trash anything? No, it'll be fine, good. If this was important, I could have got the solder sucker out, but if I did do any damage, I can fix this obviously, or I can just replace it. So that inductor, back in it goes. I thought it was a bit funny going in because I bend them down firm and I had a bit of funny spacing. So that being done, that prompts me that probably that input cap will be next. Capacitors, not the polarized ones. Oh, I could put in that 100 ohm ceramic. That should have gone down a while back. This is just for the filtering, power filtering. C4, I bet. Double check. Yes. That chicken's called Twitter. When she was young, she wouldn't shut up. And then she grew up to also not shut up. So the inputs are 47, the outputs are 100 nano. 47, what do we got? 47. So I got Illinois capacitor or Vichet. You know, much of a muchness, what do you want? I just gotta put the ICs in here. That looks like a pretty firm bend down to fit. Yep. Nice long leads, I'm gonna recycle those as well. And 100. They are not over here. They are in this box. I went through and I ordered every 100 nano cap from Element 13, Mouser, MO User, RS Components, just to see what was out there in the world, as I do every now and then. So I got like bags and bags of 100 nano, 100 nano. They all look very similar, and they all are very similar. I guess I'll just use this. 250 volt, yeah, 5% tolerance. Excellent, good stuff. That'll do me. So got a lot of 100 nanos that look the same. They're just like a slightly different part number for packaging reasons, or I like these. If you can see it. I'll do a firm bend down. So that's going to be the output. Must be C2. Let me check the bill of materials. Yes, I don't want mistakes. Wow, that does not fit. Okay, let's not use that one. That is a lot wider than that. It's not your day. So how do these compare? They're just as long, don't use them. Ooh, didn't know I had these here. Good stuff. I'm not going to know I had them there if I leave them there either. Too long. Yeah, alright, I'll use these. 100 volt, 5% Vichet. Which are taped up for some reason. That's my Mojo box. Low voltage, extra sized bits for pedals when people want parts to be bigger. People like big parts. I'm not going to kink these because I want to save those leads. And I'm just pushing it flat against the board against the desk. Flat against the board against the desk. I don't know how I got that there. Probably doing the solder suck. And that's filled through both sides now. I'm happy with that. Good stuff. So what's missing? Transistors, electrolytic caps, and that's going to be almost it. Instead I'm going to save these. I've got two divisions in this for different sizes and applications. Transistors. I'm using a 2N5088 or 5088 and some J201s. Everything's dug under here. Bear with me while I find them. This is why it's all... Oh, here they are. Two of these suckers. And it all does look pretty random down there. A lot of cat hair. That's where it collects. Crap, I left the other one over there. So yeah, excuse the mess. Or don't. Flush that down. This is a J201 JFET field effect transistor. Let's make them level. ish. I don't like doing this because if you can see when you haven't been careful if one's a bit wonky, and so I'm just soldering the middle one now. That way I can straighten them up, give them a check over. I think that's about right. Of course, by the time you get two in, its position's pretty well locked. Dang it. I've had my 2 teas and no breakfast. I'm pretty jumpy. Okay, electrolytic cap, I'm guessing that's going to be a 220. I put 220s and everything. That's my go-to filter cap. Because it's a big value, which helps. And being a 6.3mm footprint, it helps it sit upright compared to the 5mm 100 nano and smaller caps, which helps it stay neat and helps me not have to worry. I just flicked some solder there, that wasn't necessary. About getting everything looking right. There's one here. That'll be the gain cap, I guess. I missed out on. Whoops. I've just written it as 10. Yep. I'm getting short on 10s. I'm going to order them. So these caps are Panasonic M series. It says short leads because I cut it off the tape. So that's the 5mm, and it's harder to straighten up and doodly-dee. I'll just check it out, do any adjustments. I don't like electrolytic capacitors, they're annoying to straighten up. That's it, LED and the wires. I'm done with the bill of materials. I'm just going to find a project where I can copy the wire lengths, such as the Big Fuzz has the same pattern. Might be able to have a lot of glare on this. So we have 1, 2 input and output wires which go to the foot switch, the shortest one. Oh no, we need 3 on this one because there's the LED on the board. 3, they have to be the same length. Earth goes to the star grounding point on the input jack, and +9 DC. Done with that book. Strip these suckers, 2mm off one end of this, and another 2 on the other side. Earth wire 2 on one side, and 10 on the other, which I'll save. And these ones all 2. So I'm just thinking out loud to myself, I'm trying to be mindful, that way there's less mistakes, which I guess your work process is just a matter of how many things you can keep in your mind and keep rolling at. Rock and roll. Alright, this one I came out with one a little bit longer, a little bit shorter. I'm going to put the short one in the PCB end, because I know on the input, on the foot switch, there's going to be two wires together, so sharing a terminal, so rather that's got a little bit of extra length stripped off. That didn't make sense, did it? These have all come out the same length, so that's good. If they don't, it'll show. It won't be neat later, you'll see. Or you won't. And last one. And I'm just going to pre-tin the other end. Side of the door. LED will be the last thing, then I can start doing the board, loading it in. But I want to get the LED on there now. I've got a big roll of these, which I thought would be appropriate for the project. Unfortunately, the paper has gone really old and crappy. It won't matter, it's a bit cut off, but it just adds extra. But I've got them. They look cool. They look appropriate, I think. I used to not like old LEDs. I only like the clear modern type, but I've grown to like the diffusion on these old amber. Like, it will change color and it'll spread well, and it's got a wide viewing angle. I'm gonna chuck one of these over. One of the small ones, I think. Let me just think. Because it's got a switch, it should be pretty long, so a long 10mm one should be cool. I'll put it over the positive lead, because that's got potential to do more damage. If the negative lead shorts out, it's probably just going to short to earth, which is already negative, which means the LED stays on. Who cares? That's not as critical of a problem. I don't expect this to short out anyway. I don't need insulation here, but because it's sitting there, let's chuck it on. Could have gone away without it, without any problems. I'm just going to spread these legs out a bit so it sits there. It can stay there. Okay, I'm going to keep loading this up, so get the board ready. 500 kC, 50 kB. 500 kC output cap is a very strange value. You wouldn't use C's, but I am. Output caps are usually audio tape or linear. This is reverse audio, so it's pretty extreme in the opposite direction. .500 kB would have worked well too. But there's not a ton of output. It's only one transistor clipping the diodes, so you got or depends on your diode selection, but whatever the forward voltage drop of each transistor is on each side of the wave, peak to peak you haven't got a lot of voltage left, so more output I think on this circuit does work out well. I'm going to put these in without a cap, because I know if there's a switch in there later, it's going to really pull these up all the way to pretty much there. There's no chance of anything shorting out, and I can see the LED. That's not going to be too short, that little sleeve, that'll be fine. I mean, it's not going to be too long. And a single pole double throw center off toggle switch. And while I'm here, why not, let's try and get, they're very hard to pick up, got it, the dress nut hardware cap as well. So I'm going to rearrange this. Dang it, dropping everything. Oh, well, look, for that later because I'm doing a video. In the meantime, grab a spare. Or maybe I won't look for it later. Anyway, I'm going to use the hardware that came with this switch, rearrange it as a spacer so that it's pushed just the right amount of distance away from the board. I don't have to count threads. It's not going to change over time because the dress nut on the other side of this, you don't get many thread counts. Like there's like 3 threads. There's not much play to that many turns. Yeah, about 3. But yeah, anyway, let's chuck that on. No, I'll leave it off. And this is going to be a tight fit. I've changed that in the file recently. They're going to be bigger in the future to make it easier to desolder the switches. Haven't had one die, but you know, I guess one day. Keep these separated because those washers look very similar, but they're not quite. Start loading up. So this is serial number 1631. I must have a matching bottom, that's why I've serialed it already. Normally I don't put the serials in until last unless I try and make the bottoms and tops match. This one I think it was important to not damage the powder that way. Just straighten everything up. I'm trying to get that nut roughly going up and down so that there's no point coming out here, because otherwise it's going to push into the input jack or input socket, whatever wording will be most correct for you, common to you. I will need a foot switch. The mono jacks are in these stupid plastic things at the moment. I'll need a stereo battery. I don't need them, that should be cool. Just trying to think out loud what hardware I need to grab. Unfortunately, Element 13 packaged all those individually. There's a lot of plastic waste. I'm going to get the wires out now. 2 of them, input output, little link wire. I'll get the earth wire. Some hardware, double thick nut for the stomp switch, washer for the stomp switch, Switchcraft hardware, and star washers I add for a couple of reasons. That's ways to get a 0 ohm resistor. I'll lean across, fold it just right of being in the center point, clamp it over, I'm grabbing it just at the end, not twisting too many because you can actually just break the wire if you do that too much. Little crimp at the last bit. Now count this down to 3 visible threads. 1, 2, the third one's just coming through. So I count my hardware, that way each time it's the same. If there's a plate, I'll just go up or down a number of threads, and keeps everything consistent. I like taking the guesswork out of stuff and take estimations out. Pull that through, drop it on. I probably won't test this pedal in the video, just in case. It'd be embarrassing if it didn't work. It's a very simple board, I'm sure it will. Just got to tighten this up in such a way that everything's straight and aligned. I've got the star washer in there to give it some spring and some grab. How's that looking? Sometimes the light, I got to look at the top, look at the bottom, and the light throws you off and plays tricks with seeing when things are straight. I'm pretty happy with that. All right. Crimp that over. This is going to carry earth from the enclosure up to the switch. Just the star ground. It's completely inconsequential. All it is earthing the input and providing negative to the LED, so there's no noise issues, but just to have it like star ground off the enclosure if I can, and it saves cutting up Teflon wire. Okay, I'm going to put a link in here for the bypass. So the input's going to connect to the output when it's bypassed, rather than going to the circuit board. And put a little kink in it, a slow bend, feed it through, pull it up until the kink, squish it flat, fold it over, cut off the excess, and do a mechanical fold on that. Fill the whole hole. There's a tiny gap at the bottom, but yeah, I can see that's doesn't meet NASA specs, this one. Not military grade. But if you're going to go into war and you're going to take a pedal, don't bring this Tweedsville one. It's going to have plenty of length on this. Because there's no hardware here, I can have a bit more length to fold up and round. More length, sometimes the better. I don't want people yanking. Alright, I'm going to chuck this in first. As a rule, I put this before the battery, that way I know I'm not clamping the battery. It's sort of like a fail-safe. See, it's about straight, yes. And with this tool by hand, that's just the right amount of tension. That's so good. And that's going to earth it properly with the star washer, and it also packs it out, so this is pretty flush. You don't have extra length coming out the side, taking up more space on the pedal board. That's about minimum being flush. So that works out. That stuff bugs me. Okay. As many twists on it as I practically can. No. Which is probably one too many. Alright, that's all sitting where I want it. Don't breathe and it will stay there. Solder on very quickly. If I heat that up, it's going to melt the insulation and it might push itself up, and so I was swift with that one. And I'm going to tuck it in to roughly where it's going to live. It can sit there for the rest of its life. I'm going to put this little link in. This is going to send negative from the casing to the input of the circuit board when it's in bypass, to mute the input, stop any howling and any oscillation potential that it's not going to happen but could have happened. little kink in there, fold, push it in with my thumb, and that's waiting. I won't solder that yet. I'll get the one that's got the shortest insulation strip. This will be the input. Put it on a 35-degree angle. Keep it balanced upright. I don't grip that all the way. It's got just a little bit of slack so it's not pulling in too tight. Otherwise, if you try and tense it too much, it actually sort of lets go because it can fold itself back out again. This will be the most difficult wire of the pedal if they fall over or... See what I meant about that nut to being upright. If the stylus coming out, it might have dislodged the input. It's a pretty tight little layout. I'll fold that wire out of the way. Get the flux out. Get the flux out of here. And I think, oh, one more. Put a little hook on that. Crimp it down. I'm going to hold it where the insulation begins so that I'm not bending on the joint there where it's bare and going to be soldered, because that can make it brittle. Put a little kink in, feed it to the eyelet terminal. It's just pushed itself this way a little bit. I'll probably just leave it there and then cut it off at the end. If it wants to live there, it can live there. I spent a bit of time there. I don't like spending time on the switch, but the point was I had to solder this wire to that link. It's not about soldering it to that terminal, or soldering. The terminal is just there as a placeholder pretty much. It's not needed as a switch component, because that's already connected to that. It's already connected to that, regardless of how the switch is configured. Ah, crap. Let's push it out. Try and get the slack. Oh, I wish I didn't do that. Oh well. Because people are watching, of course. There. That's where I had it before. And yeah, GoPro is really killing my head. You put this hardware down. Double check, 500k C, 50k B, sure thing, and load it up. Hopefully it all matches. I like to get this one down first, so they'll hold the board in place. Hardware next. Now, this is pretty important. I didn't pre-solder the pots to the board because I don't believe in it. Not at all. People like hand wired stuff, you know, the hardware doesn't go to the board, that's fine, and there's a lot of good reasons why that's cooler. This I like, and when people do this the wrong way, it is a big problem. So what I'm doing is making sure that every circuit is soldered in the final spot, the circuit board will match the enclosure. Because I'm drilling these, there is some tolerance errors. They're all hand drilled with a jig. That should be super tight in tolerance, but it's not CNC'd, so there'll be some, even if it's 0.5 millimeter. You don't want to put 0.5 millimeter of stretch on a soldered bit of thing. It can rip off traces. People have these problems. This will not have that problem. This will have some slack. It's got the aluminium legs. They can bend up and down, left and right a little bit. But people, they pre-solder it and then they torque it and they stress them and they turn it, and I see so much crap. Sorry. I'm ranting. Yeah, things don't always get done the best way. I can give this a bad name. So I'm just making micro adjustments, slowly tightening everything up, moving everything in until it's about the right spot. Now that I think it is, I'll tighten this up the rest of the way, trying not to scratch that UV print. And that's firm now, and that's going to give some bearing to everything else. I think I just twisted the board around. And that's pretty neat. I'll push it down firmly here. You know, last chance to make any objections. No. And that cap there, it's just going to clear the box, the lid. It's got that little bit of insulation over the top, because the lid recesses a bit that way. I know that because they all do. That's the highest part. It's going to make a lot of fumes. Normally I'd have my little extractor on, but then you won't be able to hear me as I mumble. I'm holding these a second because I really want the solder to go through to the other side, start to run down the leg just a tiny bit, so I'll just make a connection both sides. Again, that's the right switch. Always check, because once you get these in, they're a bugger to get out. Unless you really have to, which you shouldn't. Smoke's coming to my face. That joint's come through a bit cold. I didn't leave the iron there long enough. I'll try it again. I'll probably do the same thing twice, and I'll add just a little bit more so there's new flux. Yeah, so now that I've made it cold, it's going to keep coming cold like a blob. I'm just going to leave that now. No, I'm not. People are watching me. Because if I change this now, it's going to be purely a cosmetic thing. And there's no need to compromise the switch, but oh, let's do it anyway. Let's do it properly. Leave it there a sec. See what happens. That's better. It still looks a bit cold. Probably due to the mismatched metals. This is nickel, then it's copper, nickel, gold. There's a lot of layers. And then lead-free solder, of course. I don't do much for cleaning, but I just like to brush off what I can. Alright, what's this mess on the end? 9 volt. Ground. So it looks like I'm smashing through this pedal pretty quick, but you got to remember just preparing the box, getting all the prep work done, communications back and forth, customer, all the admin, tax, going to the post office. A lot of the building a pedal just goes into that stuff as well. But just getting the box right and getting it there, the drilling, powder coating, the brushing, going to the UV printers, that took 5 weeks to come back. That's where a lot of the time goes to. But the final assembly is the joy. Just making it become a pedal, like in the space of an hour or however long it's been. Probably not an hour yet, I hope. Before I do that, let's chuck this in. This wire uses the stereo prongs as a switch to turn the power on and off, and there's nothing plugged in. So when there's something plugged in, it shorts out, and I'll connect the DC from the socket to the rest of the circuit. This might pop out. That's a very fiddly little joint where 2 wires are going in the same hole. Now here's that input I was telling you about, how there's going to be 2 wires again in the same terminal, and how these have to be the same length, otherwise it's going to show if they're not. It's come out pretty well. So the last bit's that LED. Oh, now that they're soldered properly, I'm just going to give that final. I don't tighten them all the way just so it doesn't twist in spot. So the LED in. I'm glad it fits. I don't know, do I want it flush or do I want it sticking out a bit? Maybe somewhere in the middle. If it sticks out, then at least it's not going to harbour dirt in the hole, but then you can also push it. Yeah, I reckon just about there.